Hello to everybody, and welcome to our newest Strong 2020 public lecture. I'm Catalina Curcianu from Frascati National Laboratory, and I'm the Dissemination and Communication Coordinator of the Strong 2020 European project. So you have already learned that we have today a very, very special lecture, which will be given by Professor Gerhard von der Streuven, and he will speak about science, policy, and truth. Before, however, leaving the floor to Professor van Streuven, I would like to tell you some words about our European project, which is hosting this special lecture within our public lecture series. So that's our website, by the way. Please go and have a look to our activities. In short, our project is studying the strong interaction at the frontier of knowledge and is being receiving funding from the European Union's Horizon 2020 program under the agreement 824093. Our project started already years ago in 2019, and it will be going on until summer of next year. It sees the participation of many leading research groups and infrastructures, which are involving practically many countries around Europe. And it also exploits what we are doing within our projects and the innovative potential which we are developing to prepare also systems for beyond fundamental physics, which have an impact in medical imaging and information technologies. The consortium is including 46 participant institutions, which are coming from 14 European member states, one international European interest organization, and one European candidate country. And together with the host institutions of 21 other countries, we are embracing in total 33 countries in our research project. And even more, we are offering access to 3 world-class facilities for doing experiments in Europe: COSI, MAMI, Frascati National Laboratory, ELSA, GSI and FAIR, CERN, and also to a special institute, which is ACT STAR, offering possibility to innovative theoretical developments in hadron physics in close synergy with experimentalists. These are the countries which are participating in Europe to our Strong 2020 project. And I already anticipated that today we have a very special lecture. And this lecture is about science, policy, and truth. And I leave Professor Piet Mulders, who is a member of the Dissemination Board of Strong 2020, to introduce our speaker of today. Please, Piet.
Yeah, thank you, Catalina. And it's a great pleasure for me to introduce Gerhard van der Steenhoven. I'll do the pronunciation as I think in Holland it should be done, because we are fellow countrymen in that sense. And I remember Gerhard. I want to tell you why he's the right person to do this talk. I know him already for a long time. When he was a PhD student at NICEF in Amsterdam, and we were now doing experiments at NICEF, but also starting experiments in Europe, for instance at DESY and also at Saclay. So there were various facilities at those times, which were in the 80s. And then we started sort of doing also international things. And I think one of the first European networks as predecessor of Strong 2020, both of us were involved. Why is he so special? Because he's not as right now special advisor to the Ministry of Interior and professor of meteorological and climatological disaster risk reduction at the University of Twente. But he, as said, I started off as an experimentalist in doing electron nucleus and electron nucleon scattering, as many of us still do. And he was taking theorists serious. So when I was talking about quarks with transverse spin and transverse momentum and correlations among it, he said, let's measure it. And he did some of it at DESY. Then after that, to stay within limits, I remember his enthusiasm on outreach and activities around that, because he became at some point a chair of the Netherlands Physical Society, and both of us were in the board at that time. I remember that. Uh, but besides being an excellent scientist, he also shows that in with physics you can do more and have a career as manager. He was a dean at Twente, and or as a director. He was for 2 terms director of the Royal Netherlands Meteorological Institute, and that's in a time when, yeah, particularly also in that field, with climate, of course, being a very important research topic, that management, politics, and research starts to come together, and that's, I think, the topic what he is going to talk about. And yeah, if you want to know, that's the triangle on the poster. And if you want to more about the network, Catalina, you want to
Yeah,
show more?
Deborah, maybe you can put back the slides, my slide. Thank you very, no, mine, Catalina. Okay, thank you very much. So, yeah, I'm here already. Oh.
Yeah, I missed the last slide, but any information can be found on the website of the Strong 2020
Yes,
website. But
yes.
I think,
So,
Gerard,
no.
we should start with your work.
That's not it. Anyway, so yes, so let's go directly to our host, and thank you very much for the introduction. And we move directly to our speaker, a very special speaker of today. And yeah, thank you, Pete, for joining me in introducing this very special lecture. Just to those who are listening to us right now, you can ask question. You can, yeah, we will answer at the end. You can ask questions. Just write them in the channel, and we'll be back at the end answering possibly to as many as possible questions. So please, Professor van Steenhoven. Oh my God, I'm terrible in that. Please, let's go.
Okay. Well, Catalina, Piet, thank you very much for your very kind words. And to me, it is a great pleasure to return to the community where I started my career as a physicist in the strong interaction physics field. And because of all the wanderings I made, as Piet just explained, I obtained a bit of experience in the wonderland of interferences between science and policy. And in the next 3/4 of an hour in this lecture, I hope to share some of these experiences with you, as I do think that when we as scientists try to help policymakers, politicians, and other people who have to make decisions, it is very useful to realize that their world is a bit different from ours. Now, if I move to the next slide, yes, that's the way I do it myself. Let me start with a very interesting example. I guess that many of you may have watched this movie, the famous movie Oppenheimer by Christopher Nolan. And if you haven't seen it, I strongly recommend that you go to the movies as soon as possible, because it is really a very interesting movie, especially for persons trained in physics. And you know, of course, Oppenheimer, the father of the atomic bomb, and he has many interactions with, on the political level, on the personal level, on with other scientists, etc. It's a very entertaining and very important movie. But there is one moment in this movie that I would like to share with you, because it somehow is a very interesting example of what we are going to discuss in this lecture. And it has to do, by the end of the movie, it has already been shown how the atomic bomb has been developed and how it has been dropped twice, marking the end of World War II on Japan, on Nicosia and Hiroshima. Then he is invited over to the White House for a discussion with the then President of the United States, Harry Truman. Now, Truman is a bit of a heavy person who really wants to say what he thinks about it. But then a very interesting debate emerges, because Oppenheimer, as is written here on this slide, feels embarrassed, feels guilty about the fact that he has developed the atomic bomb and that it has caused so many casualties in the world. And I fully understand that. And then Truman responds to this story of Oppenheimer, but I took the decision. And although the person watching the movie is more sympathetic to Oppenheimer than to Truman, in the end, Truman is right. And it is something we should not forget as physicists. We as physicists, we as researchers, we develop ideas, we develop concepts, we tell how things are changing in the world. But in the end, in a normal democratic society, it is the politicians, the ministers, the presidents who take the decisions. And it is very important, as we will see with several examples throughout this lecture, to make this distinction between the advisory role of the scientist and the decisive role of the politician, even though our sympathy usually goes through the scientist, and that will probably remain unchanged for years to go. Now, this immediately hinges to the figure which I've put central to this lecture, and that is that in this field of discussing the interface between science and policy, there's a kind of a third part of this triangle, which is labeled truth. I think that was Pete's idea, actually, because at each of these sides between science and policy, policy and truth and sciences, there's some tension, there's some issue going on. And rather than presenting a large philosophical lecture for which will be boring to most of you, I've decided to illustrate the issues that play by explaining 3 examples that you're all fairly familiar with. The first one will be on the proton spin crisis. There are 2 reasons for choosing that example. The one is that was the last issue I addressed when I was still active in the field of strong interaction physics. Of course, I checked whether my knowledge is still up to date. There's a bit of a risk there. The second example is something we all participated in and witnessed very intimately, and that's the COVID-19 crisis of a couple of years ago. And the final one is the subject that I'm spending most of my time on right now, and that's the climate crisis. And these 3 hopefully will illustrate how a rather intricate interaction between science, truth, and policy helps in formulating the measures that are often needed to change society, making use of all the scientific knowledge being developed. So before discussing each of these 3 examples, I want to highlight one example which is quite remarkable. And although I don't have anything personal with that example, but it immediately pinpoints one of the issues, and that is the role of commercial enterprises, companies. And that has the example of smoking. Now you may say, well, smoking, that is something of the past century. It is. But still, it is a very neat example to discuss this subtle interplay between the truth, science, and policy decisions. I mean, it's common knowledge right now that I'm not saying anything spectacular. We know that smoking causes lung cancer and is lethal. I mean, it is just as simple as that. It is written on every package of cigarettes you buy, if you can still buy them and afford them. But now the amazing thing is it was advertised, as you see with these old pictures on the right-hand side of this slide, as being very cool, very popular, and very healthy even. Although already in the 40s of the previous century, it was found scientifically that there was a strong relation between lung cancer and smoking. And officially proven by Dole and Hill in 1950 and a couple of years later as well in the United States. The official knowledge, the scientific, well-accepted knowledge, peer-reviewed and all of that smoking was in the end leading to death, is known since the 50s. And now the amazing part is that it took, if you're an optimist, 25 years, if you're a pessimist, 50 years, before that scientific knowledge was translated into policy measures. And the question is, Why did that take so long? And that immediately brings us to the role, in this case, of the tobacco industry. But as you can already guess, similar effects are taking place in the climate issue as well. Because what did the tobacco industry did? They apparently anticipated the growth figures that you see here on the right-hand side of this figure, where enormous, I mean, you're talking about billions of cigarettes sold. And as they were only interested in shareholder value, in profits, in making money, they decided, as a countermeasure against this scientific knowledge, to set up think tanks. An example that was followed later also in other domains. And they recruited health scientists saying, well, we are going to make R&D calls, etc. But they formulated all these calls in such a way that they were able to create doubt about the existing papers. And that is actually not very difficult, because we all know, as good scientists, that you present your result always including a margin of error. You're never 100% sure. We are scientists. We say, well, it is most likely, it is very probable that there is a 10 or 50% probability that the answer is slightly different. And people can make use of that uncertainty, and in that way create what I call jump science. So these think tanks were incredibly successful. I must say, that's really a pity, but that's the way it is. And he also started to influence decision makers, lobbying as it's called. And in effect, as you see in the lower graph here on the right, the end of the smoking epidemic took 40 to 50 years. And if you realize that as a toll, it costs 1.5 million of smoking casualties every year, it is incredible that no earlier measures were taken. And you see how powerful this measure of think tanks is, and how important it is to realize that indeed there is a difference between science and truth. Okay, that is just as an example to start thinking about all these issues. Let me now move to the bulk of the lecture and treat the first example. And as I said, when talking about the proton spin crisis, it still feels vaguely familiar, but you have to bear with me that as of 2008, I started doing other things in my life. And of course, with this little eye, I still follow the proton spin crisis. So I use it as an example, but I may make one or two mistakes, but so be it. The proton spin crisis is extremely interesting. I guess most of you know the story that in the 80s of the previous centuries at CERN, the EMC experiment, found out that somehow the quarks only carried 0.1 or so of the spin that had been expected from the normal quark model of the proton structure. And we all thought it is very simple. Proton is a spin a half, quarks are spin a half. You have 2 up and 1 down, and that's all there is. And as soon as you discover that apparently your hypothesis, your truth, is not true anymore, it's easy to raise a number of questions. I mean, if you're a nasty person from outside our field, you will say, well, have scientists lied about the quark structure? Is our truth changing with time? And what's then the validity of all their statements? And what's the effect on non-scientists? So before addressing these 3 questions, let me just give you, maybe it's mostly to myself, in 2 slides, an update of where we stand nowadays as far as the proton spin crisis. And I couldn't resist showing you this very funny cartoon, which probably is still truth, whether this little discovery of a pyramid in the desert is similar to the discovery of EMC in the 80s of last century, whether it is really a major discovery or simply something complex which hasn't very deep roots. We still, at least I still don't know, maybe Pete knows. Okay, what has been learned from a number of experiments at various labs, that indeed the spin of the proton has at least 4 constituents. It's the quarks, the gluons, and the orbital or angular momentum carried by the quarks and the gluons. And well, that seems to arrive at a consistent picture, although it would be valuable to add some more experiments and work to that. And what you learn from this relatively simple example for people working in this field is we see this as a normal evolution of knowledge. We have a cycle of experiments, we see certain things fail, we develop further concepts, and in a very valuable way, single spin symmetries, transversities, orbital angular momentum was added to our knowledge base when we talk about spin structure. And actually, Piet Mulders, who introduced me, was a key figure in introducing concepts like transversity. And that seems all normal and standard to us. But now, with that knowledge and looking through the glasses of somebody from the outside, what will he see, or she, of course? Have scientists lied about the quark structure? Well, obviously not. We didn't know better. Is our truth changing? Yes, our truth is changing, but we call it, of course, knowledge evolution. But the real big concern of these three questions is, what is the effect on non-scientific persons? And they are looking for yes and no type of answers. And how will they perceive the evolution of knowledge as we see it? And that brings me to the last slide on this part of this example. What my experience is when talking to policymakers and politicians is that they want to have a yes or a no, 100% predictable outcome. That's easy. Then they can talk about it without any vagaries in their expressions, no doubts, and that it's easy when they're in parliament or when they have to talk to opposition people. They say, well, this is what science says, it is blue and it's not red, so the issue is clear. So it helps them enormously. But of course, the reality is different. In practice, a scientific program, but in fact also a societal program, has uncertain outcomes, uncertain deliverables. And the public, as we will see later on in the climate crisis, may respond different to what people expect. But we have to realize that the fear of the policymakers is indeed that anti-science movements are taking the floor, because they will say, well, if you're not quite certain about the origin of the spin of the proton, then why reserve additional budget to sort out this problem? Then we might better spend it on another way. Or, well, those people don't understand at all what they are talking about. So this difference between the underlying truth and our scientific endeavors is important to realize, because it is actually feeding the anti-science movements. So much about the first part of this triangle between science and truth. Let me move to the next one. The COVID-19 crisis. Again, I can't claim a lot of expertise here, but I think we're all equal experts, given the fact that we all participated or were victim of this crisis. And you remember how the virus was spreading throughout the world, leading to over-occupied wards in hospitals, social distancing, you remember, and actually locked down areas where you couldn't go because of all the dangers it might involve. You have to realize that you may have forgotten that in effect we had three waves of the coronavirus. And the first one was in spring of 2020, then in the winter 2021, and then early 2022 the final wave. And each time the governments try to develop policy measures to reduce the effect of this pandemic, and each time the public was responding, and it was a very interesting, let's say, dynamics of public response, scientific advices, and government action. And the measures we all remember as well. I mean, there were lockdowns, there were masks we had to wear, and of course, most importantly, a new virus. In fact, several vaccines were developed. And it's actually interesting to remember that just 2 weeks ago, the inventors of the biotech vaccine were awarded, for good reason, the Nobel Prize in Physiology and Medicine. So that seemed to be all fairly convincing. And before going to the societal issues that emerged while all of this is happening, it is good to provide you with two background slides, a little bit about how the virus was spreading, and some other aspects on policy making, because that sets the background before we discuss the big societal issues that emerged in relation to the corona crisis. And let me see. There I am. So one of the remarkable things is that when you talk to the experts in epidemiology and pandemics, they say, well, it's very simple. Pandemics emerge when a virus jumps from an animal to a human being, which is with an official term called zoonosis. And in the case of COVID-19, it's also clear that's a jump from a bat, and these flying little horrible animals, to a human being. And it is usually pointed out that somewhere in Southeast Asia that may have occurred. And now there's a very interesting relation to climate change, because according to this paper that you see here quoted on the right, climate change has caused a mobility of bat generations, of bat communities. More species developed, and they were growing rapidly, and they moved up north. Is obviously because temperatures in the north were rising, and in the south they were getting too hot. And it may well be, and that's a suggestion of this paper, that due to climate change, this increase of bat species close to Wuhan may in fact have increased the probability of this zoonosis process, causing in that way the trigger of the corona crisis. And a second piece of information, also a bit related to the climate issue, is that if you see what people did, you remember there were lockdowns, and people were asked to stay working from home and reduce their travels and all of that. It was immediately observable from space what the effect was of these measures. Here you see a picture taken with the tropomi instrument on Sentinel-5P, a meteorological instrument, and that's why I knew about it and learned about it. On the left, you see the normal emissions of nitrogen dioxide, NO2, during a normal week in spring in 2019. And on the right, you see the same spot observed. That's above the Netherlands. Okay, that's because I'm living there. In the first week after the lockdown in this country, you see an enormous reduction in red areas. That is an enormous reduction in NO2 emissions. And as such, when you're talking about policy and science, this is actually an extremely encouraging picture. And rather than be negative about all kinds of interactions between science and policy, this is actually a very positive one. And that's the reason I want to show it, is because here you see that if the policymakers, if the politicians take a measure, we say, okay, less travel, stay at home, and shut down the factories, etc., you immediately have an effect on the environment. And that is actually a hope-giving conclusion. It turns out that policy measures, when taken in a proper way, are very effective, and that's good news. So, in that sense, I didn't want to skip this slide, but really share this with you as well. But now the issue. After about a year or so, somehow a war against vaccines emerged. In many countries, in the United States, Canada, Europe, we had demonstrations against the lockdown, against vaccines, and it really puzzled me, probably because I'm a scientist. And I mean, when you look here right down about the number in millions per day of people being infected by the COVID-19 virus, how can you start protesting, whereas the way to save people is at hand? So this is really something that puzzled me, and that's also why, and of course, at that time I was director of the Meteorological Institute, and we had to take measures as well. We had to send people home, and some people were protesting, and you have to get answers. So and you have to talk to the people making these policy measures to make sure that you have the right arguments and can convince your own employees to follow these measures. So this is an issue which has always puzzled me. If I then showed scientific data, and I just downloaded some recent graphs from the cloud, of course. I mean, these vaccines are incredibly effective. I mean, look at this table on the left. Of course, the BioNTech and the Moderna virus, I mean, with effectiveness in the order of 94%. And this analysis that appeared last year in the Financial Times, that this is the number of casualties recorded and modeled due to corona or COVID-19. And this would have been the number if there had been no vaccine. I mean, that would have led to 20 million excess casualties in our world. I mean, that's quite incredible. And nevertheless, these protests emerged. So I found this a very intriguing issue. And in order to get close to understanding this difficulty, I first want to show you what an example of what I call the Dutch mistake, but actually it may have a wider effect than just happening in the Netherlands. What you see here on the right is one of the first press conferences issued by our Prime Minister here on the left, Mark Rutte, and he did that together on equal footing with the head of epidemiology of the Health Institute RIVM, Jaap van Dissel. His name is written over here. And if you think about that, that was an utter mistake. And they realized that they made a mistake because 2 weeks later, the press conference was only given by the Prime Minister and not together with this guy, Jaap van Dissel. And why is it a mistake? Because if you treat the science advisor, this guy with the gray hair and the beard, on equal footing with the political decision taker, all kinds of nasty effects emerge. And you see it kind of in a cartoon-like way written over here. They're all corrupt. I mean, if you hate the government, and in a democracy, there are people who hate the government on the left side or the right side, I don't care. This type of presentation starts equating the importance and also the brotherhood, if you wish, between the politician and the scientist. So the criticism that is sometimes correctly and sometimes incorrectly directed towards the politician, this guy, is immediately taken over by the scientist, whereas the scientist just tries to stay close to the facts, to the scientific findings, and the politician should have the courage to say, well, listen, this is the advice from the scientist, but I also have financial, political, or whatever considerations. And that's really one of the lessons that I drew from the Corona crisis, when we had to work on this issue in our environment and defending that against other people, that you should avoid a full association between politicians and scientists, because it is advantageous for the anti-science people, because they say, well, in as much as we have doubts about this political party or this politician, we immediately extrapolate that to the scientists as well. And it also eliminates, and we've seen that happening as well in the Netherlands, eliminates the freedom of politicians to say, well, this is the advice, for instance, on wearing masks to reduce the effect of contamination, because there may be other consideration, availability, support, financial considerations, other issues that are more important, like education of youngsters, isolation of young people. So to me, this was a big lesson that indeed one should always have a distinction between the scientific advice and the political consequences, which may not be identical, whereas in this case, they made them identical. So in my view, what the policy people should do, they should give full credit to the science, recognizing that it is important, including all the uncertainties, but be transparent on what aspect of the advice they follow and what they don't. Because please realize, people are not stupid. If a scientist starts defending the policy measures, then somehow they feel, and that's what we have seen happening on television, that it is not entirely sincere. Okay, so much about the Corona crisis, and actually the relation between the overall theme of this lecture on science, policy, and truth is largely, I've largely already expressed that when discussing the previous slide. Be aware that the policy decision is not the same as a scientific advice. There may be other consideration, and the politicians should always make this distinction between their considerations and what the science is advising. Otherwise, they give room to the anti-science movement. And now I have a small problem, and that is because the size of my file, this is something entirely different. I have to stop this presentation and start the next one. And I'm not quite sure whether I'll do that or let me see whether I click on this one. I need some advice. Can I stop this presentation? Yeah, here, I can stop this one. Yeah, and now I can start hopefully the next one. Or yeah, it works. Great. That was a bit of a trick in the preparation, because I had to switch to another file. So now the final example on climate change that I would like to share with you. Well, climate change, clearly, I had to work and talk a lot about this subject when heading the Meteorological Institute in the Netherlands. And therefore, I choose this example as well and share some of the experiences I had with you. But it's important first to make sure we're all on equal footing. So I'll first spend 5 slides or so on reminding you about the basics of climate change. And that's not very hard, because if I only take last summer, 2023, we all remember the numerous heat waves that were striking the northern hemisphere of our planet. You see them all here. And also, if you focus to Europe, we had these heat waves in Italy and Spain, and floods in Slovenia and Austria. A lot is happening to our atmosphere, and a lot that we are seriously worried about. Now, the issue that is really important at this stage is, why is it that climate scientists are so convinced that actually the climate is changing, and that these events, these floods and heat waves are not just, well, I mean, these happen. I mean, we remember heat waves from 20 years ago, we remember floods from 30 years ago, and still we now believe that all these indicators and all the indicators that we have our atmosphere really show that the climate is changing. And I need to make that argument first before addressing the relation to social people who are denying climate change and all the social developments. So allow me to spend just a few slides showing the basics of the argument of the climate scientists, why we are convinced that indeed the climate of our planet is changing. And it essentially all starts with ice, the ice caps on our planet, on the North Pole, on the South Pole, on Greenland, the glaciers, what have you. This is an example of the North Pole, where in the past this entire area used to be covered by ice in September. And now in September 22, you see it is much reduced, some 40%. And that is a systematic trend, as you can see here on the left. Since 1980 or so, on average, the ice cover on the North Pole is 40% less than it used to be. And similar plots can be made for Antarctica, for Greenland, for the glaciers. So we see in science, without any doubt, that all ice masses throughout our world are melting. Well, that can only have one reason, and that is that the temperature of our atmosphere is rising, which here you see 5 different groups trying to measure the rise of the global temperature and translate that into one average number, which is a science in itself. But you see all these groups in the end agree that since 1850 or so, the temperature of our planet is about, on average, 1.2 degrees higher than it used to be, more on the North Pole and less at the equator. And the origin of that problem is also very well understood. It's the enhanced greenhouse effect. Here, in a kind of an educational fashion, the CO2 layer is depicted with this dark gray band. And the essence of the argument is that CO2 and other greenhouse gases are behaving in exactly the same way as a piece of glass in your living room, meaning that it is transparent. The windows are transparent to visible light, and they are not transparent to heat radiation that come from parts of the planet that are heated up. Think about the warm sand that you feel in your feet when you make an evening walk over the beach in summertime. And just in full analogy with the greenhouses that you have in the agricultural domain, if you increase the thickness of the glass, more heat will stay inside. In a similar way, if you increase the thickness of the CO2 layer, the Earth will warm up. And indeed, when you look at the evidence, indeed, the CO2 layer is increased in thickness quite considerably by more than 30% in the last 50 to 60 years. And that has led to this cry of urgency from the IPCC, depicted here on the right side, that if we want to limit global warming to these levels agreed in Paris, then we have to take rapid measures to make sure that the rising CO2 emission levels shown over here are not continuing on this way, which will lead to a 3-degree warming of our planet, but rather start reducing the emission of CO2 as rapidly as we can. This is a relatively easy story. And as opposed to the proton spin crisis, this is not rocket science. This is not something where there are many basic uncertainties. In fact, here I can show you a newspaper clipping from 1912 where exactly this same argument has already been made. So that's the frustration of many climate scientists, that we are talking here about textbook science, well developed, well publicized, many times repeated and reproduced, and still people are somehow not buying it. And here you can read, it's actually quite amazing. This tends to make the air a more effective blanket for the Earth and raise its temperature by several degrees, written down in the year 1912. And to make the issue even more strongly, this is a graph taken from a book published in 1975, almost 50 years ago, half a century, where the later Nobel Prize winner Manabe made a very simple first climate modeling study, doubling the CO2 level of that time. By now it is already much higher. And in fact, correctly predicting in a very simple way as a function of altitude and latitude. So this is the equator, and here you have the North Pole. The changes in temperature, here you see 6 degrees, 2 degrees, and in fact a negative effect in the stratosphere, all completely confirmed by the data. So this is just in a few minutes trying to show you how solid the understanding and the science of climate change is. And just to finish off, I almost have forgotten this one. How is this then related to the extreme weather events, which are of course the most deathly and the most costly of what's happening right now in our world? This is an accumulation of the World Meteorological Organization, an enormous number of disasters, deaths, trillions of economic losses. How is that related to the basic understanding of climate change? It's good to see that as well before we talk. Before we go to the societal issues, that's explained on this elementary graph, which I often also use in lectures, etc. What you see here is the distribution of, for instance, temperature, but one can also do it for precipitation, of temperatures in a given country, whether it is Italy or the Netherlands, it doesn't really matter, only the average point will be different. This is 9 degrees in the Netherlands, and it will be 14 degrees in Italy or so. But the basics is, this is the old climate, where now and then we had freezing temperatures in winter with truly cold weather, and rarely in the Netherlands you had a summer day above 25 degrees. And what climate change is doing, it is pushing this distribution to the right, meaning this 9 becomes 11 degrees, still not very distinguishable, but it is a somewhat higher temperature. You hardly have any freezing days anymore, many more summer days, and now and then even days above 40 degrees. And this is exactly what is happening, and why extreme weather events that are sitting over here are in fact the little birds in the coal mine, the signaling that something is happening, although the average change is not really something you will sense from on a day-to-day level. So far about the basics of climate change. We understand why the extremes are changing. We understand why the temperatures are going up. We know what we have been doing. It is due to the human emissions of greenhouse gas effects. So it is an understandable and in that sense tangible problem. Why then are people denying this? It is like when I gave a presentation of this sort some time ago, a person came to me and said, well, you explained all of this to us in 15 minutes. It's completely clear. Why are people not buying it? And that's what I try to explain on the next 2 slides, because there is something odd. Why do they deny scientific evidence? And that could be valuable for other application areas as well. The first thing is that people have a certain reluctance in changing their lifestyle, which is obvious. I mean, if you are accustomed to flying twice a year to some beautiful spot elsewhere in the world, why would you change it? And that may bring along new risks. So a change in lifestyle is threatening. But maybe even more importantly is the effect on the business model of companies. Because look at the fossil fuel industry. If we will stop using oil and gas and coal, it means that these companies have huge stranded assets, so there's useless reserves with oil and coal and what have you, dwindling profits for the top management, and of course, an enormous reduction in shareholder value. People don't like that. I mean, they are primarily profit driven, which is something you may discuss as well, and they want to prevent this situation from happening. And finally, there's also this issue that it may not fit your way you believe that the government should behave. Because if you take massive measures against climate change, the government will become more powerful. And many people with certain political feelings say they don't like that because a growing government is against their concept. So then you get all these kinds of funny advertisements suggesting the untruth of climate change, despite all the scientific evidence. So what is being done? And now you will see an interesting analog with the way that the tobacco industry behaved when I explained about the activities against smoking regulations. What the oil companies did is they created so-called independent think tanks, funded with relatively huge amounts of money. I mean, look at all these millions of euros written over here, and this is the 2019 number. And they created these think tanks, again, with the possibility to develop scientific arguments why climate change would not happen. And it has happened in the Netherlands as well. You see it everywhere. And they use a range of arguments. And then they try to be convincing, say, well, scientifically, it cannot be true that such a small part per million level of CO2 can affect our entire planet. Of course, anybody who has a background in physics or chemistry knows that this is utter nonsense. I mean, catalysts are just behaving that way. There's the economic denial. Well, it may all be true, but let's face it, economy is most important. People may lose their job, so forget about it. Economy is more important. There's the humanitarian denial. Well, you all know if you add a little bit of CO2 to your plants, they will grow faster. Yeah, sure. If you add something, that doesn't mean that it may be good if you increase it a little bit for your plants, but it doesn't mean it is healthy for our planet. It is like, well, eating is healthy, but indefinite eating is very unhealthy, as we all know. There is the political denial. Well, why should I do something? I'm just living in a small country. That's the big countries, China and the US, take the lead. Before that, I won't do anything. And these things are, of course, happening. Crisis denial. Yeah, it may be an issue, but well, okay, we have survived climate change now for already 20 years, so we might as well survive for another 10 years. All these arguments are used, and in my view, neither one of them is convincing. But be aware when these are being presented in newspapers and on talk shows. Usually the other people at the table don't give any valid counter arguments, whereas these counter arguments are relatively easy to come up with. So, but now here's the surprise. People have been fighting against the climate science, but it has not been successful. And that's the amazing part. And this is one of the most hopeful slides I have in my slide deck, because this is a questionnaire, a review being conducted in the Netherlands by a social research institute, SCP. And what we see, despite all these activities of these think tanks, of the fossil fuel industry, 90% of the people being asked realizes the climate is changing. 80% realizes we have to change our lifestyle. And 70% or so, indeed, is willing to take action. That's a well-known effect, according to social studies, that people believe, well, if the industry and the government have failed, they should solve the problem. But these numbers are enormous, and they are not unique for the Netherlands. If you look at this table, you see many other countries with maybe slightly less, but still very high numbers where people realize climate change is real and we should do something about it. So this is a very surprising situation. Despite the millions and millions of euros invested by the fossil fuel industry, nevertheless, the public doesn't buy it, so to say. And that brings me to the lessons learned from this example on climate change. Despite these investments, the public understands the truth. People should not underestimate the smartness of the common man in the street. The only problem is that all these investments on think tanks has postponed the decision taking by at least 20 years and probably 30 or 40 years. And that is, of course, an issue. So there is also a lesson that if there are scientific reasons to stop with the production of a certain product or change your CEOs, companies should accept that they also have a social responsibility and not only a shareholder values. Or shareholders should also look at companies with a social view. And the policymakers should be realizing that they are not only successful if the GDP of a country is rising, but also if the social well-being is increasing. And that's, of course, not as easy to measure, but it's clearly an issue that needs to be addressed. Well, how is all of this related to the original theme of science, policy, and truth? The lesson learned is that also in the climate issue, uncertainties should be taken seriously. And you should nevertheless have this distinction, as we have seen from COVID as well, even if some issues like how much more droughts will we get in the Netherlands in 2050, how much sea level rise we will get, that there are uncertainty margins. Nevertheless, you should take measures because that's better and safer for society than not taking any measures. Be sure you only recruit advice from publicly funded scientists rather than some commercially biased think tank, and be aware the public is smart. And therefore they should ignore fake news and be honest about uncertainties. Like, we take this measure knowing that the sea level rise, as an example, is still uncertain by, let's say, 0.5 meter, but we know that it will rise anyhow, and therefore we do A, B, and C. That is the story about climate change in a nutshell, but nevertheless, and it is time after 3/4 of an hour to reach some conclusions. And then there's, of course, room for questions. I've tried to summarize what we learned from these 3 examples on this slide with the 3 examples mentioned. As far as the proton spin crisis is concerned, I think that the difference between science and truth has become apparent there. We all know that, that's a familiar example. But in the good sense, it has also led to, as a driver for future research, because funding agencies have been willing to provide additional funds for new facilities to discover, to research this question in more detail. So there's a very positive side, but the negative side on this axis is that indeed anti-science movements continuously make use of the difference between the two to elaborate their arguments why no measures should be taken on COVID or the climate. As far as the COVID crisis is concerned, I think there's a very clear lesson to be learned. There's a difference between scientific advice with all the uncertainties attached to it and the actionable policies. Wearing a mask may not be 100% proven to be okay in reducing the chance of contacting COVID. Nevertheless, there could be very good reasons to convince the audience to wear these masks, also as an awareness that this pandemic is still going on. And as far as the climate crisis is concerned, the policymakers should be aware, and that's probably the most surprising aspect of that part of the discussion, that the public, after a while, is able to make a distinction between fake truth or fake news and real news. And just to conclude, this is, I think, the key issue. Be aware. There is not an equation like truth is science is policy. They are different realms with their own dynamics, and you should always be aware that these 3 are different. And then you can, with that knowledge, you can start approaching, as a scientist, your policy friends or any person you meet outside our domain. To conclude, there are some signs of hopes. It would be bad to conclude the talk without some positive feeling rather than all these sometimes negative developments. I was very pleased in the last couple of years to read that despite sometimes funding problems, there is still an active community to further try to solve the proton spin crisis. So there are good funding agencies who are aware that this issue, this strong interaction issue, is worthwhile further investigation. The COVID-19 crisis has brought us the mRNA technique with the Nobel Prize of 2 weeks ago, and that is now applied to other diseases and could be very profitable for healthcare in general. And as far as the climate crisis is concerned, despite all the efforts of the oil and gas industry to suggest that the climate is not changing, we see now that, especially in Europe and Germany, the increase in renewable energy is starting to take on really serious forms. In Germany, the first half of this year, 57% of the electricity was produced in a renewable way, and you see a similar curves for all electricity in Europe. The renewable one going up, even now being larger than the fossil fuel one, and this is the nuclear one. So I hope that with this lecture, I've somehow illustrated some of the aspects at the interface of science and policy making. But I would not like to see that you become pessimistic, because you see that in the end, it is possible for science to convince the policymakers in a reasonable way and to take the good measures which lead to the signs of hope shown on this slide. Thank you very much.
Thank you. Thank you very much. It was really, really very, very inspiring. And I'm very thrilled to have had this lecture within our public lecture of our Strong 2020 project. And I invite people who are following us, if they have questions, to just write them in the chat so we can address them to our public lecturer today. Meanwhile, I take advantage to ask you a question myself. So what do you think we as scientists can do more in this regard?
Yeah, that is. Thank you, Catalina, for your kind words. That's what I should say first. Piet was mentioning the importance of outreach. I think that's always important. And I think that we often have a tendency, when we talk to policymakers, is to tell them about the beauty of science, which is fair enough. But we should always add two things. The one is always be honest and sure about your margins of uncertainty. But the one thing I didn't mention, which is probably the most important thing, try to listen to the policymaker. What's his need? Just as an example, at a certain point a number of years ago, we found out that the Ministry of Education in the Netherlands was interested in a new iconic project. And then you can say, okay, we could work on a gravitational wave detector, we could work on this or that, etc. Try to identify what is the need of the other side of the table. And then you can provide them with opportunities. And that is the same if you talk to climate deniers or people who are against smoking or whatever. Try to listen to the other side of the table, and then you find out that often the underlying thing is not really scientific, but emotional or political or whatever. Listening to the other side is probably the hardest, because we're all so fond of our science and so enthusiastic about the achievements of science that we forget to listen. And that's actually really, in my view, the critical part.
So I assume it happened to you to speak with denials of whatsoever, which in spite of talking to them, they didn't change their mind.
That's true, yeah. And they didn't change their mind. I mean, in the Dutch parliament, Piet knows this, the strongest voice against climate change is a guy called Thierry Baudet. And once I had the opportunity to talk to this man for 2 hours. And I brought the best climate scientist in my institute with me on my side, and he had all good arguments. It was very strong. The effect was zero. So here's another lesson that I didn't mention, and that is that you often, I mean, we did it in the old-fashioned way. We tried to convince him with all the good arguments, but his interest was entirely different, we found out. He was not interested in the science at all. He was only interested in political power, in seats in parliament. And he knew by appealing to the anti-science movement, he could get whatever 10% of the electorate. So it didn't matter what we said. It was irrelevant to him. He had another agenda. And that is actually so amazing to experience this as a scientist. Okay, so your agenda is not scientific at all. And that's the reason why I say, listen, if you listen to the other side, then maybe you have at least an idea why the communication is failing.
Let me give a service communication. Deborah, can you take out the slides so we remain? Oh, thank you very much. And were you very much frustrated about that?
Initially, I was frustrated about it, certainly, because you have the feeling that you've wasted 2 hours, and also with other climate denier. There's even a foundation of climate deniers in the Netherlands with whom I had frequent contact. But at a certain point, I realized it is smarter to stay in touch and now and then have a cup of coffee with them than to fight them publicly, because then you are doing exactly what they like. Because then they say, well, look at these arrogant people at the National Institute of Weather and Climate. They're always thinking they're right. And so then they're, again, not using scientific arguments, but publicity arguments to draw a black and negative picture of you as an institute. So these are, at the level of maybe not principle, but tricks where you realize that we would help the Dutch society much better, and that applies to most Western societies, to just keep talking to them and be a bit slow. Whereas as a scientist, I used to try to be fast, but there I had to be slow. That was much more effective.
Pete, you are muted.
Mute. Yes, let me also take the opportunity to ask a question. I mean, in science, we are used to debate a lot about what should we do, a linear collider or a circular collider or whatever, bigger, whatever. And but you can say we are doing scientific experiments in which we see if we can repeat something, and even if something is discovered. I mean, we wait for a next opportunity to verify it, even if it can only be seen initially at CERN. But of course, our atmosphere is a very delicate thing. Suppose that we now scientifically say, yeah, but we should do something on CO2. So let's, on a huge world scale, try to reduce it. Such a thing is, of course, going to give you a lot of political turmoil, because what decision should you take? You can only do it once if you want.
Well, we have one example that's called the atmosphere of Venus, which is for 90% CO2, and we know the effect. The temperature is 450 degrees at the surface level, so we know that that's a bad example. But as far as CO2 reduction is concerned, there are two aspects to it. In the end, of course, there is an equilibrium between the CO2 content of the atmosphere and the oceans, and the temperature and pressure, etc. That's an entire system in it. And now, with the human efforts of the last 60 years, this system is brought out of equilibrium. So if we can take steps to bring it back to equilibrium, at least the direction is safe. But there might well be, as a physicist, you will understand that, hysteresis. There's no reason to believe that the path towards the previous equilibrium will be the same as the path out of the equilibrium. Most likely there is some hysteresis, because we see from the oceans, who have a very strong inertia. They respond very slowly as compared to the atmosphere. But also CO2 stays in the atmosphere for 100 years. So that's really a complex system. But the way we approach that is kind of twofold. The first one is, as exemplified by the Green Deal of Ursula von der Leyen, make sure that our emissions are brought back to zero, to at least reduce the rising and stop as soon as possible. If that doesn't go fast enough,
we have seen that as a good example of CFKs.
Yeah, the CFKs, there the policy measure of the Montreal Protocol of 1988 shows to work. The CFKs, which caused the ozone hole, indeed now have been reduced, and the ozone hole is gradually being decreased right now. A very nice example, actually, of a successful interface between policy and science. the discussion that is now taking place among climate scientists is whether we should develop techniques to actively remove CO2 out of the atmosphere. That is called carbon dioxide removal, or CDR. And CDR, that there are already pilot plans on Iceland and in Switzerland and in the United States. But the level at which that needs to be done at the gigaton scale is still approximately 6 orders of magnitude removed from what is now technically feasible. Still, I am very much in favor of developing this technique and scaling it up, because it may well be our last resort to prevent the temperature of the Earth from rising any further. So as a kind of a safety valve to ensure that we have at least one technique to address this problem. But now comes the interesting thing. The only organizations who are able to do upscaling from laboratory scale technique to gigaton scale are the fossil fuel industry. So here is a very funny discussion that I have with several of my colleagues from the Oceanographic Institute, from the university, etc. That we don't like the fossil fuel industry so much because they have polluted the atmosphere in a horrible way, but we might need them in order to get the CO2 back out again. These are one of the amazing dilemmas that you are confronted with. But I do think that humanity is wise if they develop this CDR technique, because it is unlikely that all the countries across the world are equally successful in implementing climate mitigation measures. I'm fairly hopeful actually about Europe, as we've seen those electricity figures, and the awareness in Europe is quite good. But imagine that the next election in the United States has an outcome we all fear, then that might be dramatic.
Yeah, I can imagine that. And anyway, it's quite surprising, at least for me, that people do not believe in things which, as you have shown, are in front of our eyes, while they are very easily convinced about dangers which are absolutely totally crazy. Like if you remember the fact that a black hole produced at LHC will destroy the world. It's quite
well,
yeah.
It is interesting. These inquiries about the public ideas about climate change came as a surprise to me as well. Although I've seen similar studies over the last couple of years, typically with rising percentages of the acceptance of climate change as a fact. Here is one advantage as compared to smoking, although I don't fully understand it. I mean, the climate is changing as we speak. Everybody is witnessing these horrible heat waves, is witnessing these floods, etc. So people see it happening every day. What surprises me in hindsight, why that mechanism didn't work for smoking. Because we all have in our family friends of the previous generation who passed away because of lung cancer. So why did the very clear signals of smoking and how dangerous it is not work, whereas now it seems that these climate dramas seem to work, at least in several parts of the world? That's, I mean, the interface between physical studies and social studies is very, very difficult, and so this is one of the things I don't understand. That's the numbers for the COVID crisis are more similar to that of climate. There, in the end, 70% or so of the people do get a vaccine and make sure that they prevent getting COVID-19. But for smoking, somehow maybe because it all started earlier. I don't know.
Do you think that more science education at the school level would be beneficial, or it's kind of disconnected?
No, I do think that is beneficial. And the one thing which I often find a bit puzzling is people say, well, you shouldn't bother school children with the difficult subject of margins of uncertainty. There I disagree. I mean, every school kid is playing games. and knows that whether he or she throws a 6 or a 3 has a very large margin of uncertainty. So start educating margins of uncertainty, because it is a mistake to think that people can't swallow these error bars. I mean, look at the weather forecast. The weather forecast carries a band saying, well, tomorrow it will be 16 degrees plus or minus 2 degrees, and the band will grow if you go further in the future. All people understand that. There's no magic about that. We find it all pretty natural that the uncertainty about the weather 2 weeks from now is larger than that for the forecast for tomorrow. Playing games is exactly the same. You know it is uncertain whether you throw a 6 or a 3. Make use of that at elementary school when educating people in science, because that is the type of basic knowledge that could be so helpful in understanding and appreciating these developments.
Yeah, I fully agree. Yeah, I don't know, Pete, do you have other questions? You are muted.
Oh,
Still muted.
No other questions right now.
Okay, don't see other questions
Thank you.
coming. However, if there is anyone there who might even see this video later on, if you have comments or questions, just send us a mail and we will get sure that they arrive to the right place. And if you allow me, I would ask Deborah, who is our host, invisible host today. She has organized and kept us online, Deborah Bifaretti from Frascati, to whom I wanted to thank very much. Deborah, if you are there, yes, thank you very much.
Thank you.
I want to thank Deborah and to all the office in Frascati of Dissemination and Communication for making this lecture materially possible. And of course, I thank very, very much to Professor Gerard van den Steenhoven. Oh my God. Maybe Pete, you can help me with the right pronunciation just to not end up with a badly pronounced name.
Bedankt, Gerard van der Steenhoven.
Thank you very much.
You're welcome. Okay, thank you very much for providing me with this opportunity. And indeed, if there are any further questions, you just send me an email and I'll try to answer these questions.
Thank you.
Okay.
Bye.
Bye-bye.